All right, so last time I looked at characteristics of tropical marine climate, and we noted that tropical marine climate has high temperatures all year round with very small diurnal range. Additionally, also realize that these areas experiencing tropical marine climate also have two distinct seasons, a wet and a dry season, and rainfall is experienced right throughout the year. There's no extended period of no rainfall. The only things that you have wetter seasons, wetter periods of rainfall, especially when it is warmer, and periods of dry periods, right? So we want to now look at the factors which accounts for the characteristics of this climate type. When we talk about factors influencing climate, there are some general factors: latitude, altitude, ocean currents, winds, cloud cover, length of day. Those are some general factors affecting climate. However, when we look specifically at marine climate, tropical marine climate, and the characteristics of the climate, two factors are the driving force behind the characteristics of the climate. These factors are trade winds and the sea. So the trade winds now, which are winds that blow steadily, and in the Caribbean region from an easterly direction, they blow over the sea and across the islands throughout the year, throughout much of the year, right? And what they do is that they influence the type of rainfall that we experience because these trade winds take with them moisture bearing air. And when they come up on a physical obstruction in these islands, like for example a mountain, these moisture bearing winds are forced to rise on one side of the mountain, producing rain on that side of the mountain, while on the opposite side of the mountain, that area will get little to no rainfall, right? We don't need to look at tropical rain types of rainfall, so I'm not going to go into detail as it relates to explaining rainfall. But the trade winds influence the type of rainfall that we experience, and it is also responsible for bringing some type of relief from the hot temperature in the Caribbean. So it normally take with it cool winds, and it gives us some type of relief from this hot, dry climate that we're used to in the tropical marine area. Additionally, we notice that the difference between maximum and minimum temperature is not very high. That is what we're referring to as I am referring to as the diurnal range. And for example, highest temperature 28, lowest 24. The difference between 28 and 24 is what? 4 degrees Celsius, right? So you realize that the temperature almost look steady during the hottest months and the coldest months. So that difference between maximum and minimum temperature would make it seem as if the temperature is the same throughout the year, right? Other factors might influence the temperature, like if you're on the top of a mountain, it might be cooler than an area that is not high. So don't I don't want you to get the impression that there's nowhere in Jamaica that is very, very cold at one point and is very, very warm. You do have those um types of I don't even know what word to use, but for want of a better word, extremes. And that's for want of a better word. So let us now look at the objectives. As I said, we're looking at the factors, or we're looking at we're discussing in detail one factor. So we're actually looking at the C factor because it's the most influential factor influencing this type of climate. So we have a poem here which was taken from Carlon Social Studies, and I am not a poetic reader, so please forgive the absence of that poetic tone. All right. Oh, how I love the sea breeze, the cool sea breeze that blows from the sea as the day wears on. It it cools the air, it stirs the trees. It relieves the heat of the broiling sun. Solid heats faster than liquid, you say? So that is the reason the sea keeps cool and the land heats faster during the day? Well, I will try to remember that rule. When the sun heats land, air rises near the ground. Hot air rises, leaving space on the ground. Cool air from the sea around flows right in to take its place. Where the warm air is rising, pressure is low. Cool air sinks, causing pressure to be high. To bring back balance, winds always blow. From high pressure to low pressure, now you know why. So right here, realize that it tells you about sea breeze. It it speaks about how the land is warm versus how the land is heated versus how the sea is heated. It introduced two terms: rising pressure, no, high pressure, and low pressure. So you know that low pressure systems are hotter. I mean, all I know that, right? And low pressure systems are hot air, and high pressure systems are cool air. High pressure systems, the name has to do with the weight. So because the pressure system is high, it's cool, so it presses down on the atmosphere, right? Hot air now rises, so it's light, so it's a low pressure system. Hope I'm not confusing anybody. I felt a little confused a while ago, but I hope I'm not confusing anyone. So when we talk about islands, right, or coastal areas, we realize that there are two features present: the land and the sea. The land being solid and the sea being liquid, right? So with this now, we need to talk about, and with the sun coming out, the sun heats the land and the sea. However, we need to look at some science. So let us look at some important facts as it relates to science and how solid versus liquid is heated. So solid heats faster than liquid. This was stated in our poem earlier, right? That the solid land heats faster than the liquid sea. Why? If you look at particles, let us look at little science for a moment. If we look at the particles here, right, in the solid, we realize that they're closely packed. Solid is heated by a process called conduction, heating process called conduction. So this particle here is heated, then it is transferred to the next particle, and it continues to transfer because they are packed closely together. So heat transfer from one surface to another, from one particle to another, is simple. There's no space, the particles are not moving around, they're only vibrating. So heat transfers faster, so it takes less time to heat up. When we look at liquid now, the molecules in liquid, they have spaces between them. So liquid heats slower than solid. Reason? The spaces between them. And liquid is heated by a process of convection. So because of the spaces, the molecules move around in the liquid, and as they move around, they will heat up other molecules, and then the liquid will eventually become heated. This process takes longer because they're moving around, and you have to wait until the particles become attached or touch each other for the heat to be transferred from one to the next. However, solid is already compact and together. So there's no movement, there's only vibration. So the heat is just transferred swiftly through it, while there's delay in the solid because of the spaces between it. All right, so that's one rule we need to write down. Solid heats faster than liquid, and I've just explained why. Another rule. Liquid loses heat slower than solid. So just think of we having a cup of tea, a big mug of tea, and a fried dumpling, and we're having our breakfast. Both came off the fire at the same time. But what you notice that your dumpling get cool or get cold before your cup of tea gets cool, right? So the molecules in liquid takes a longer time to loses the heat than the solid. So two rules: liquid land heats faster than the sea, and the sea retains its heat longer than the land, right? So we have them two rules are locked. So sea breeze now. So during the day, the sun is out and the sun heats up the land. So this is the land over here, and this land heats faster than the sea. So therefore, the air over the land will be warmer than the air over the sea. So over the land, you will have rising air, while over the sea, you will have descending air, right? So when the air over the land rises, it creates, let me just use this as just for example purpose, it creates some type of space on earth. So because there can be no air space on earth, cool air rushes in from the sea and takes its place. So that is how we get that cool wind, and this type of warm air rising, cool air rushing into takes its place is what is responsible for the breeze, for wind, for producing winds. So as again, during the day, warm air rises, and when the warm air rises, it goes to upper levels of the atmosphere. Cool air is over the sea because the sea takes a longer time to cool. It rushes in and takes its place, right? Producing sea breeze. At night, the opposite occur. So at night, let's see my second, let me just look at this. So the warm air over the land will rise throughout the day, causing the low pressure at the surface. So this you can read through all by yourself. We're going to go to the what happens at night now. So at night, the opposite role occurs, right? So the air over the ocean is now warmer than the air over the land. So the rising air is now over the ocean or over the sea, while the cool air is over the land. So as the warm air over the ocean rises, cool air from the land rushes in and takes its place, right? So the the sea now is responsible for keeping the land warm at night still, because that difference in your pressure, that difference in pressure now, and because the islands are not very large and they're really surrounded by the sea, that natural regulation in temperature is held. Also, the winds along the coastal areas bring light and scattered showers in coastal areas also. So the sea influence also influence the type of rainfall that we experience. But you can read this. All right, and that's it as it relates to land and sea breeze.